Hello and welcome once again. In this video, we will study about one of the best common source amplifier. It is active load common source amplifier. Before going into its detail, let's first understand the drawbacks of current source load common source amplifier. If you haven't seen my previous video yet, then watch it first and then come back to this video. Now focusing on shortcomings of current source load common source amplifier. Number one is there is a trade-off between the voltage gain and voltage swing. The voltage gain of amplifier is compromised for large voltage swing. And second drawback is that to achieve high output impedance, the width and length of M2, that is this load transistor, should be high. And this leads to larger load capacitance at output node, which results into poor transient response. So transient response is very important of the amplifier. To counter these drawbacks, we can use CMOS concept. Let's see how it is done. If we replace the load transistor with the PMOS device and provide same input as we are giving to the NMOS driving transistor. So this topology is called active load common source amplifier. Here PMOS act as both input and load device. So this is the circuit diagram and M2 is the PMOS device, you should note down. So you must have studied this topology as a CMOS inverter. Yes, this is exactly the same amplifier. Let's understand that how it deals with the voltage swing and gain. First of all, we have to bias both M1 and M2 in saturation. So this mode is important. Now as V input, as V in increases by a small value, then ID1 also increases, which pulls down the V out. So V out decreases as ID1 increases. Now at the same time, this M2 injects less current, that means ID2 decreases into the output node and it supports this action of dropping of V out. So V out gets lower down more. In this way, both M1 and M2 support each other, leading to a greater voltage gain without compromising with the output voltage swing. Now moving ahead, so this is the small signal model of the amplifier. Here in this small signal model, the channel length modulation resistances of the MOS transistors are come in parallel, so form the total output impedance of the amplifier, and GM1 plus GM2, it is the total transconductance of the amplifier. So simply the voltage gain is given by the total transconductance product the total output resistance, that is R out, and this is our GM with negative sign. Now let's compare all the common source amplifier that we have studied till now. So this is the comparison table. Here we will focus on active load version, and active load version has moderate voltage gain but more stable. It is more stable and it depends on the aspect ratio only. It has moderate linearity, better than this resistive load and the current source load amplifiers. Most advantageous feature of this active load amplifier is its low power dissipation. It occupies a small area on chip, and active load shows large voltage swing, and it is better than other topologies of common source amplifiers. This is the voltage gain and output impedance comparison table. Here you should note down that the output impedance of current source load and active load common source amplifiers are same, but the transconductance of active load is larger than the current source load versions, which facilitate better voltage gain in active load common source amplifier. So this much in this video. In the next video, we will study about the last common source amplifier, that is source degenerated topology. I hope you like the video, so please share your feedback in the comment section. Thank you so much and have a nice day.